Hello everyone. In this session, we are going to see about sorting algorithms in data structures. Sorting is one of the most important operations in normal any data wherever we are using, whether we are arranging any mark sheets or any data or any ordering names or building efficient some search engines in your real-time applications. So wherever we use data, the sorting is one of the main parameter or one of the main work we will do it over there. So why sorting is important? So for example, in a library, we have thousand number of books which all are unsorted. Then to find a book is always very much tougher. In the same library, all the thousand books are in sorted order. Then to find a book is very much easier and efficient one. That's why sorting is very important in normal places. So, for example, in normal data structures, why do we require an corresponding sorting? So, we will sort a data by means of either ascending order or descending order. It is always used as a building block for an advanced algorithms. That's why we require sorting in a DSA. So in DSA itself, there are two types of sortings are there: comparison based and non-comparison based. So comparing means what? We'll compare one data with another data, one data with another, and then we will keep on sorting your data. That is called comparison based sorting. While in non-comparisons, we will use some techniques and then we will sort your data. So today in this session, we will see about an insertion sort and bubble sort, which comes under comparison sort, So now here you can see this like playing a cards. On the left hand side, I have a sorted cards, and the right hand side is a new card. So what do? I will take a new card. I'll compare with the left element, the first element. Okay, I'll compare the right hand side card with the left side first element. Okay, then if it's lesser or not. If it's lesser, I will insert over there. If not, I'll take a second value, I'll compare it. And then third value and compare it. And fourth value and compare it. And then wherever it is correctly going to fix it, I will insert over there. That is called insertion sort. It will shift the elements by one and inserting right element in the right position. So here you can see example. So here, this is the order. So now I have taken 17 as a key element. 17 as a key element. And then 70, I'll compare 17 with 25. So now what happens over here? 17 is lesser than the 25. So I will keep it in the first place. So I will swap it. So now in the next iteration, what do? I will take the third element. In the second position is 31 is there, right? I will take that as a corresponding element. So 31 compare with 25. It's already smaller number is in the lowest position. And 31 with the 17 already in the lower position. So then I will take 13 value. I will compare with 31. So I will swap it. At next once again 13 with 25. I will swap it. And 13 with 17. I will swap it. The next iteration I will take the 2 with 31. I will swap it. 2 with 25. I will swap it. 2 with 17. I will swap it. 2 with 13. I will swap it. So it consists of n minus 1 passes. Okay, where n is equal to 5. So 4 passes in the fourth iteration. Okay, so this is the basics of an insertion sort. So this is the coding for the insertion sort. I have a loop, the for loop, the outer loop, and then here while. So while we'll check for that. So in the key, I have taken as a second element. Okay, always in the array we have an array of 0, 1, 2, 3. So in the first iteration, what we have done over here, we have taken this as a key element, and then we have compared with the previous values. So now here also you can see I is equal to 1. So key is equal to array of 1. And then the j is equal to 0. Okay, I is equal to 1, right? So 1 minus 1 0. j is 0. So j is while j is equal to 0, j is equal to 0. And then I compare the array of 0 is greater than the key or not. In our case, what is the value? Array of 0 is 25. 25 is greater than the key, 17. So now what do I do over here? Array of j plus 1. So in the array of 1 position, I'm going to store the value called 17 over there. And then I'll decrement say j minus minus. So to j becomes 0. J becomes 0. And then in array of 1 position, I will put a key. I will put a key. So then once again it will repeat the loop. Every time the path will be keep on going on. Understood? This is the process of an insertion sort. Next one is a bubble sort. Bubble sort is nothing but the movement of generally in the water. Okay, if you throw a stone over there, the bubbles will come at the top. Okay, so that's what the movement of air bubbles in the water that rise up to the surface. Each element of the array move to the end in each iteration. Therefore, it is called bubble sort. It's simple. In every iteration, the largest element will come at the last. The largest element will come at the last. That's a bubble. So now we'll try to go to the example. So now in the first iteration, we will compare the two adjacent elements, minus 2 and 45. So 45, which one is always the smaller number should be in the left hand side and then larger number should be in the right hand side. So it is already in the same position. So then 45 and 0. So I'll swap it 0 and 45. And 45 and 11. So I'll swap it 11 and 45. 45 and minus 9. So I'll swap it. So at last this iteration 45 has come to the last position. So now in the next iteration I'll perform comparison for the remaining 4 datas. In the first iteration, I compared it for the 5 datas. After first iteration, 45, the largest element has come to the last. So I'll compare the next 4 elements. So minus 2 and 0. So already is there. 0 and 11, it's already there. 11 and minus 9, I'll swap it. So minus 9 and 45. Okay. So now what happens over here? Minus 9 and 11. Okay, this should be the data. Okay, this should be the data, the highest element in the last 2 positions. You don't see this. Okay, you don't see this. This is the last step. Okay, so 45 is the last and then 11 is the next element. So next we'll perform for these 3 datas. So minus 2 and 0, it's already there. 0 and minus 9, so I'll swap it. So these 3 are sorted. These 3 are sorted and these 2 are unsorted. So in the last iteration, I'll take the minus 2 and minus 9. So minus 9 goes to minus 2. So this is the array has been sorted. So now what happens over here, after every iteration, the largest element in an array comes to the last position, So now here I have this is an norm for every iteration. So I is for iteration. In every iteration we are comparing, right? That is the second loop. In every iteration we are comparing. This is a J. This is a J. Okay. So here you can see I is equal to 0. And then here you can see we have given n minus I minus 1. So because for every iteration, the largest element will be keep on reducing. The number of elements we are comparing is going to be keep on reducing. Because in the first iteration, we have compared 4 iterations. We have compared 4 comparisons. 1, 2, and 3, and 4. So since we have 5 data, there are 4 comparisons in the first iteration. In the second, we have 3 comparisons. In third iteration, we have 2 comparisons. In last, we had 1 comparison. So that means that this j, the last one will be keep on reducing one by one. 5, 4, 3, 2, 1. So that's why j less than n minus I minus 1. So at first I is equal 0. So at first j will be less than 4, and then j will be less than 3, and then j will be less than 2, and then j will be less than 1. So this is for comparisons, and this is for I is for iterations. In each iteration, we will perform n minus I minus 1 comparisons. Okay, that is the logic for the bubble sort. So in this session, we have covered about an internal sort and insertion sort and bubble sort. The insertion sort is nothing but comparing the key with the one by one, and then we will insert at the best position. Bubble sort is all about the largest element will come at the last position for after every iteration. So this is an two types of which belongs to the comparison sorts. Okay, in the next video, we will see about a selection sort and merge sort. Thank you.